In May 2026, astronomers pointed the James Webb Space Telescope at a galaxy that formed less than 2 billion years after the Big Bang, and found something that made no sense at all. The galaxy wasn't spinning, no rotation whatsoever. That trait belongs to old, mature galaxies, the kind that have had 10 billion years to settle down and stop churning. This galaxy had barely any time to exist at all, and yet there it was, sitting completely still, as if it had skipped billions of years of cosmic history. That single galaxy is just one piece of a much bigger problem, one that has been building since Webb's very first images arrived in 2022, a problem some astronomers are now calling a genuine crisis in cosmology. Here is what the Standard Model predicted. After the Big Bang, the early universe was hot, chaotic, and mostly hydrogen and helium. Gas needed to cool, collapse into pockets held together by dark matter, and slowly build the first stars. Those stars needed to live, die, and seed the universe with heavier elements. Only then could real galaxies begin to form. And even then, the model predicted they would start small, tiny, irregular. Something like 100 million stars at most, a fraction of the size of a galaxy like our own Milky Way. Big, structured galaxies were supposed to take billions of years to build, assembled slowly through countless mergers and collisions. Webb broke that prediction almost immediately. In 2023, astronomers found 6 galaxies dating back as far as 500 million years after the Big Bang, and they weren't small. One of them had a mass 1 trillion times that of our Sun, 10 times the size of the Milky Way, sitting in a universe that was supposed to be too young to build anything that large. One researcher on the team described the discovery in a single word: bananas. She said the early universe simply should not have been able to organize itself that quickly. Then came JADE's GSZ-14, a galaxy discovered at a distance corresponding to just 290 million years after the Big Bang. At that point in cosmic history, there had not been enough time under the Standard Model for gas to collapse, form stars, build heavy elements, and assemble a structured galaxy with visible features. And yet the galaxy was there, bright and clearly defined, forcing physicists to propose increasingly unusual explanations. That early star formation was somehow far more efficient than anything in our models, or that dark matter behaved differently in the early universe than anything current theory predicts. In 2024, a separate team found a galaxy called ZFUD S7329, roughly 11.5 billion light-years away, and when they studied the light coming from its stars, they found something stranger still. The stars themselves appeared to have formed 1.5 billion years before the galaxy should have even existed under standard cosmology, meaning this galaxy carried structure and stellar populations pointing to an origin earlier than the universe's own timeline for galaxy formation allows for that mass. By 2025 and into 2026, the pattern had become impossible to dismiss as a handful of outliers. Webb identified over 1,000 spiral galaxies resembling our own Milky Way, sitting in an era of the universe when violent, constant collisions were supposed to make fragile, well-formed spiral structures essentially impossible. A separate 2025 survey of more than 250 galaxies found most of them chaotic and still merging, exactly as the Standard Model predicted. But scattered among that chaos were galaxies like the one found in May 2026, calm, structured, and motionless, sitting in the same era as their turbulent neighbors, as if they belonged to a completely different chapter of cosmic history. To be clear about what this does not mean, it does not mean the universe is younger or older than 13.8 billion years. It does not mean the Big Bang did not happen. The broad framework of how the universe evolved on the largest scales remains solid. What is being challenged is something more specific and, in some ways, more interesting: the detailed recipe for exactly how fast gas turned into stars, how efficiently early galaxies built themselves, and how quickly structure and order could emerge from cosmic chaos in the universe's first few 100 million years. One astronomer summed up the feeling perfectly. She compared it to watching 2-year-olds behave like teenagers. not impossible exactly, but completely unexpected, and demanding an explanation nobody has fully settled on yet. The universe, it turns out, built itself faster, bigger, and more efficiently than any model predicted it could. And every new image from Webb seems to only deepen the mystery rather than resolve it. Subscribe, because next time we're covering the black hole Webb found that appears to have formed before its own host galaxy, a sequence that, by every rule we know, should be physically impossible.